Hello everyone, welcome back to another video. And today we are gonna start with our new chapter, which is waves. It is a part of physics, and let's start with the definition of what wave exactly is. So, wave, we can also say a mode of transferring energy from one point to another. Let's see with the example of Mr. Stickman. As you can see in the first image, which is Mr. Stickman is holding a rope. So in the second image, as you guys can see that this Mr. Stickman has just given a jerk to the rope and this rope has made a wave. So as you guys can see that kinetic energy has changed into a wave energy. First the rope was over here. In the next time the rope just came over here. So this was a prime example that I gave you about how energy was transferred from one point to another. Firstly, the rope was still, and then Mr. Stickman just gave the jerk to the rope, and then as you guys can see, so it continues. Okay, so as you guys can see now, we are gonna do the type of waves, and we have two waves, which is the first one is a mechanical wave, and another one is an electromagnetic wave. And if we talk about the mechanical wave first, okay, so let's talk about the mechanical waves. And mechanical waves that needs a medium to travel from one point to another. Now, you're gonna ask me what a medium is. So, medium is basically called a medium is anything that carries the wave by letting its particle vibrate. We can also take an example of the solid, liquid, or gas, because in the medium, any solid medium or liquid medium or even a gas medium has a particles. So in the mechanical waves, the wave needs a medium. Okay. Okay, so one thing that I'm going to tell you about the mechanical waves are these waves cannot travel in a vacuum. These waves will never ever travel in a vacuum. And the example of these waves are sea waves, sound waves, waves in a spring, waves in a rope, as we saw that in our first example of Mr. Stickman, and also the seismic wave, which is basically called as the earthquake wave. Okay, coming to the electromagnetic wave. Electromagnetic waves which do not need a medium. Okay, so electromagnetic waves can travel in both mediums and in a vacuum. What vacuum is an empty space, so mechanical waves cannot travel through it because there are no particles to vibrate. For the mechanical waves, mechanical waves can only travel in a medium, they cannot travel in a vacuum, and the electromagnetic waves can travel in a medium as well as in the vacuum, and vacuum is an empty space. So coming to the example of electromagnetic waves, which is the X-ray, UV ray, infrared ray, gamma waves, microwaves, radio waves, and light waves, and together they make a spectrum. These seven rays and waves make a spectrum. Okay, so one thing that I'm going to talk about the electromagnetic waves, which is that they emit their own particles of energy. They do not take source of molecule for their energy transfer from the one point to another. Like if you talk about the mechanical waves, they need any source of molecule. But but when we talk about the electromagnetic waves, they do not take any source of molecule for the energy transfer from the one point to another, as they both can travel in a vacuum and in a medium. Okay, so let's just sum up with all the general wave properties today. It was just a little bit briefing about what general wave properties are. I hope you liked the video. Just give it a thumbs up and subscribe to our channel if you haven't. Until then, enjoy your day. Goodbye.